Hi everyone. So today we are going to kind of detour from my original plan for today. We're going to start with proofs, but we'll hold off on that until tomorrow. I had a few students yesterday indicate that they wanted some more practice with quantifiers, which is perfectly fine. This is definitely not the easiest thing to grasp the first time around. So we can spend one more day on this. And so I wanted to just make a video about how to actually implement these quantifiers rather than just giving their definition and then their negations. Eventually, this is a skill that you need to develop and need to acquire. If I give you a definition and if I give you negations of different things, you should be able to apply them right away or with a little bit of practice. So this isn't going to be an every time sort of thing. We can't always keep pausing because my goal here for everyone is to get into the habit of learning these things independently and trying to complete them on their own. With you guys going to college next year, that's something that you're going to have to get used to, and that's been my goal for this class for the whole year. So with that, we are just going to pause just because you still are in high school, so you still get that opportunity, but don't get used to it because it's not going to be an every time sort of thing. So let's just go ahead and start with the first example here. So we have these variables and predicates defined. So variable X represents any park in Essex County, the variable Y represents any dog in Essex County, and the predicate P is a sentence: in park X there is dog Y. So we want to translate the following statement into plain English. So we have the for all quantifier here. So I'm just going to zoom in a little bit. We have the for all quantifier and with variable X. So that would be, we can say in every park in every park there exists at least one dog. And there are a lot of ways that you could write this, but we're just going to stick with this. So in every park, so the every quantifier, and then at least one dog. So the next one, in every park there exists exactly one dog. And then we keep going, and so in at least one park all dogs are there. So all dogs in Essex County are in at least one park. And then in at least one park there exists exactly one dog. And then our last one here, in exactly one park every dog is there. So that would be each statement. Again, there are a few different variations that you could have here that kind of say the same thing depending on your verb usage or your prepositions. As long as you're saying roughly the same thing, that's fine. As long as you have those quantifiers in there and the sentence makes sense, then you're good to go. For The next one, this one is taking a sentence and putting it into its logical form and then doing the negation of that logical form. So let's go ahead and take a look at these variables and predicates here. So variable X is any book in Newark Public Library, P is a sentence, X is paperback, and Q is a sentence, X is hardback. So the first sentence we have here, if at least one book in the library is paperback, then there exists exactly one hardback book. So we have a lot going on here, but the foundation of this sentence that I see is an if-then statement. So I know I'm going to have an if-then statement involved. So the if part is the at least one book in the library is paperback. So I'm going to write this as so at least one, so and there exists quantifier. And so we have X here, and they're saying that the book is paperback. So there exists X, P, and this is the if part. So I'm going to put this whole quantity as the if statement, and then this is the implication part is that there exists exactly one book that's hardback. So there exists exactly one Y such that Q. So now I need to give the logical form of the negation. So if I were to negate this whole statement, again, the backbone of this statement is an if-then statement. So I need to remember, how do I negate an if-then? Well, an if-then is the first if part stays the same. So here, the beginning part is going to stay the same. So there exists X such that P, and then it turns into an and statement, but we negate the then part. So we would need to negate there exists a Y such that Q. And so to actually go ahead and simplify this out, we would have there exists X such that P. And now again, to negate an exactly one quantifier, we get an or statement. So I need to be careful with my parentheses here. Let me move this over so that we aren't saying the wrong thing. So I'm going to have a set of large parentheses or even a bracket here. And let's just go ahead and put another set of parentheses. So our first statement would be for all Y, not Q. And then that's our first, and then this is an or statement. Or there exists at least two. So this is the notation for at least two, such that Q. And excuse me for my error here. These should be Y's, not X's. And then again, note that Q is not negated in this statement. We are not negating Q as the negation in the second half of this or statement. So Q stays the same here, but it does get negated in the first half of this or statement. So if I put this back into logical or plain English, the negation here, so our whole connective here is an and statement. So I'm going to start with the word both. So both, there exists a paperback book and so now I have this and here, and then the next sentence structure is an or statement, so I'm going to include the either. So and either all excuse me. I apologize. I just got lost for a moment because I'm using a Y that I don't need to be using. So let me fix that throughout because we don't have a Y variable in this problem. So I apologize. all of these should be x's, not y's. So if you're wondering why the heck I'm using a y, I should not be. You are correct. So I got caught up there because I was wondering. I was like, well, what is y defined as? I don't have it defined because it doesn't exist. So either all books are not hardback, since that is not Q, or there exists at least 2 hardback books. So that is what our negation is saying here. Okay, so moving on to the next one here, the last one. We have for all books in the library, either the book is paperback or is hardback. So here, the overarching statement is for all books in the library. So this is going to go on the outside. So for all books in the library, so for all X, and then either, so this is paperback or hardback, that is our predicate. So usually we would have for all xp or something like that, but here we don't have a defined p necessarily. The second half of this is going to be an or statement, so we have p or q. So that's what this statement would look like. And then to negate this whole thing here, we negate the first part. So negation for all is that there exists. And then we need to negate this or statement. So using our De Morgan's laws here, we would have not P and not Q. So this would translate to there exists at least one book that is both, or we can say neither, sorry, is both not paperback and not hardback. And so that should be kind of intuitive for you here, because the original statement we have is for all books in the library, either the book is paperback or the book is hardback. That should be every single book in the library, right? You can only be paperback or hardback. But then here we're saying at least one book is both not paperback and not hardback. Well, that doesn't exist. So that is clearly the negation here, because the original statement is true for all books, and then the statement is false for all books. So we can be sure logically that we have definitely done the negation for this. Okay, so there is a classwork assignment that follows this example, so go ahead and complete that. I will be on the Zoom call at 1 o'clock, so please join us there for a question and answer session. All right, have a great rest of your day, everyone.